Hello, ladies and gentlemen. Welcome to the midterm conference of the DECON Tools projects. My name is Hamed Askari. I'm part of the research team of the DECON Tools projects. In this panel, we are going to speak about decommissioning of offshore oil and gas structures, as well as subsea operations. But why do we have this panel in this conference? There are a couple of reasons that we devised this session in this event. The first reason is that there are lots of similarities between offshore oil and gas industry and offshore wind industry, especially in terms of marine operations as well as subsea operations. The second reason is that offshore oil and gas industry is much more mature than the nascent and young offshore wind industry. They have significant accomplishment. We have to learn the lesson from oil and gas industry, and we have to convey the lesson learned as much as possible and applicable into offshore wind industry. And lastly, there are lots of equipment, tools, and machineries which are initially designed for the offshore oil and gas. Nevertheless, we can use them in offshore wind industry. There are just a couple of reasons that we devised this panel in this event. In this panel, we have 3 speakers from 2 well-known organizations and companies. I would like to introduce the first and the second speaker, Captain Mahmoud Reza Ilyati, the CEO of the Horizon GmbH, and Mr. Bidawadi, the Technical Director of the Horizon GmbH. So, hello, Captain Ilyati. Hello, Mr. Bidawadi. Thanks for joining us.
Hi, Mr. Askari. Thank you very much.
Thank you. How are you doing, sir?
Thank you very much. I appreciate it.
Okay, so please, before going to your presentation, I would like to ask the audiences and the participants, in case of having any question, on the right side of your screen, you can see a question module. Please write down your question in the questions module. So after the end of these speeches, we will have a 15 minutes time for the question and the answer. We will try to answer the most of your questions as much as the time allows us. So Captain Ilyati, the stage is now yours. Please go ahead.
Thank you very much, Mr. Askari. Good day to everyone, and thank you for your patience you will extend it toward this presentation. Today we are going to discuss about the application of seabed survey for pre-decommissioning for offshore wind park. I would like to introduce myself. My name is Mahmoud Reza Ilyati. I am the CEO of Horizon GmbH, who's located in Germany, and is to address the issue of European water. My earlier experience with deep sea offshore, which I am also representing as CEO, is the company located in UAE, and the operating area is the Middle East. Our area of capabilities are indicated in this slide. It's including geophysical seabed services, UXO survey services, ROV services, diving services, geotechnical services, positioning services, photogrammetry and remote sensing, and as well as engineering services. I'm already 37 years in this business, starting in 1985, and since 2011, we are fully concentrated in subsea operations in Middle East. In this slide, you will see the numbers of track records the company gains during this 10 years of operations, which is mainly indicating the survey capabilities. Since I am the presenter for the second day, addressing the preparatory activities, engineering for recovery of offshore wind park, and the time is short, I will hand it over the presentation to my colleague, Mr. Bidabadi, who is the technical director of the company, and he will continue with the technical part of the presentation. Thank you.
Good day, ladies and gentlemen. Today we want to speak about the application of the seabed survey in oil and gas, and also for the pre-decommissioning of offshore wind parks. At the first, I want to explain briefly about the application of seabed survey in oil and gas. For any oil and gas, we have different stages from explore to decommissioning of the structures. In each phases of this oil and gas development, we need different type of the seabed survey. So for the seabed survey, for the explorer section, we need to do the seismic to find the potential area which are including of oil and gas. And then for the appraised section, we will using a drilling rig to do the drilling in the nominated area to make sure that the field is live or not. For this purpose, we need to do the geophysical survey, geotechnical survey, UXO and rig positioning for the rig. And also, after a successful appraisal of the field, the client should develop the field by installing the new structures, such as the platform, such as the pipeline or cables. Even for this target, we need to do the different type of the seabed survey, such as geophysical, root survey, geotechnical, rig positioning, and also jacket and pipeline installation positioning. By developing a field and client reaching the production, so in that time, we need to do the periodical inspection of our assets, such as the platform, such as pipeline, and also do the required positioning service for some drilling rig or some other vessels which needs to be worked near our structures. And at the end, after the passing the lifetime for our structure, it needs to be decommed. So now we want to speak about the seabed survey application for decommissioning of offshore wind park components, which are separated in 4 types: wind turbines, submarine cables, high voltage substation, and meteorological mast. So for the decommissioning of these components, we need to do the different type of the seabed survey. The objective of doing the seabed survey for pre-decommissioning of the offshore wind park components is identification and removal of the debris which are maybe located near our structures or near the roots. Even one of the dangerous for our decommissioning operation would be the UXO. So we need to discover and report the possible UXO which are located in our area for the working. For the removal of the cable, we need to know the crossing objects that maybe have the crossing to our target cable. Maybe some pipeline or cable have crossed the pipeline, and we need to specify its position to recover the cable. One of the most important for our project is the depth of the buried cable. As you know, the cable from the structure toward the shore have been buried. And for the recovery of this cable, we need to know the position and depth of this cable. This target will be achieved from the seabed survey. Also, the existing protection, the status of existing protection around the monopile, a special marine habitat or marine archaeology maybe would be existing near a structure should be detected and reported to concerned parties, and also in-service or abandoned assets such as the cable or pipeline should be detected, as well as the topography of the seabed. So for achieving these targets, what we should do for the seabed survey, we need 4 types of the seabed survey categories for the pre-decommissioning of activities. The first one is geophysical site and root survey. The next one is UXO. The third is visual inspection and debris removal, and the last one would be the geotechnical survey. In the next slide, we explain briefly about each of these activities. For doing the survey, obviously we need a multi-purpose DP survey vessel to be equipped with our geophysical, UXO, and ROV inspection equipment, such as this vessel is belonging to our company and ready to do all of above mentioned operation. For doing the geophysical site survey, we need some equipment. The equipment that we need to be used for the geophysical site and route survey, which means the geophysical survey around the structures and along the routes of the cable. We need surface positioning by using the accurate DGPS and gyro compass to provide the positioning of the survey vessel, as well as the data which are achieved by the survey sensor. The bathymetry data, which means the topography of the seabed, will be provided by using multi-beam and single-beam echo sounder units, and side-scan sonar equipment will be used for the scanning of the seabed to detect some possible debris or other objects such as pipeline or crossing which are located on the seabed. The magnetometer system is one of the important systems that we need for the geophysical route and site survey, because it will detect some ferrous object, especially for the cable. For our purpose, where the cable is buried, this system can detect the buried cable. Since we are using some underwater sensors such as the side-scan sonar towfish and magnetometer towfishes, we need to use underwater positioning system to provide the position of these sensors. This target will be achieved by using USBL or SSBL units, and at the end we need the sub-bottom profiler unit to provide the profile of the subseabed layers. The most important point is that by combination of the sub-bottom profiler and magnetometer data, we can specify the position and the depth of the buried cable. After doing the geophysical survey, we should submit the reports. For the reports of the geophysical site survey and route survey, we will provide two types of the report. The first one is the text report, which explains the used methodology or vessel equipment and personnel, and also the result. The result will be including of the details of found possible object and debris, condition of subsea layers, and detail of the detected magnetic anomalies. Also in the chart, as you can see, one of the sample of the geophysical site survey charts, the data around the existing structures such as wind turbine, high voltage substation, and meteorological mass will be illustrated. You can see the sample of multi-beam echo sounder, which shows the topography of the seabed around the existing structures such as the platform, and also the side-scan sonar data, which shows that some pipeline or other object around the existing platform. Another report which will be provided after doing the geophysical survey will be the final report and delivery for geophysical route survey. The same result of geophysical site survey will be provided, but the difference is in the type of the chart, which is the alignment sheet charts, because we are doing the survey along the route from the structure toward the shore, and also the buried depths of the cable will be reported. By using the sub-bottom profiler and magnetometer data, you can see with sub-bottom profiler data, we can detect the seabed layer and also subseabed layers. If there is any cable, we can define the position and extract the position from sub-bottom profiler data as well as the depths. Even magnetometer data will provide us the position of the crossing to the cable. So at this stage, geophysical survey already done. Now we should do the UXO survey. The UXO survey has some more parameters to do, because this survey can have the risk for our purpose. So for this planning, we need some parameters. The type of the UXO that maybe we should find it. This data should be provided by our clients, that which type of UXO can be found in our area. The local marine environmental data, such as the depth of the area, seabed sediment, can be extracted from the geophysical survey, and we should do the planning for the UXO risk strategy, because for the UXO survey, one of the goals is to minimize the position that need to be visually inspected after the UXO survey. In normal practice, two types of the methods for doing the UXO survey will be done. One of them is using the towed gradiometer, which is including of an array of the magnetometer system and will be towed behind of our vessel. And another one is using the ROV mounted bracket for the surveying of the gradiometer along the field. So by this equipment, we will do the survey, and after the completion of the fieldwork activities, we should provide the reports. the report of the UXO survey will be including of the some text reports and also some charts. You can see in the right side a sample of the chart for the UXO survey. In the UXO survey, the gradiometer, which is our array of the magnetometer, will provide and specify the area that would be possible to be included of the first object. We are not sure that these are UXO or not because we need to do the visual inspection. So after doing the geophysical survey and UXO, we need to do the visual survey to check the reported the debris and the possible UXO to make sure that these are needed to be removed or recovered or not. Another part of the UXO survey report will be including the details of found possible UXO, risk analysis for doing the visual inspection, and also the suspected area. As I told you, the visual survey after doing the geophysical route survey and UXO would be required because we need to check visually that these reported debris or UXO are actually there or not. Maybe some other object would be there. Even we should do the visual survey around the structures. We have some structures such as the wind turbines, such as the meteorological mast, and most of the time there are some assets around these structures. So we should do the visual survey to check the condition of this asset which need to be decommed and also the protection around this area. And at the end, if we found some debris and specified by client that need to be recovered, we should do it the debris removal. For doing this task for visual survey and debris removal, we offer to use world-class ROV. Maybe the question will be raised that can we use diver? We say yes, we can use diver, but why we recommend ROV? Because the ROV has some advantages versus diver. Because the ROV has very quick deployment in related to the diver. The dive times is very extended in related to diver, and most important point is safety improvement, especially for visual inspection of the UXO. If we use ROV, it's very more safe than diver. You can see some sample of the recovered debris by a ROV. Then the ROV recovered the debris from the seabed and located on some basket. And if these debris were heavy, by using the vessel crane, we will recover the debris to the surface. Even the sample video of the similar jobs is illustrating here, but I think due to short time, maybe we can pass this slide because the time is short and we are near our limitation time. So another target from the seabed survey would be the survey of marine habitat or archaeology around our structure. You can see in this slide that one appraisal well which are installed on the seabed has been detected by geophysical survey equipment with multi-beam and side scan sonar data. And also we did the visual survey around this structure to find that is there any marine habitat or archaeology around it or not. You can see the video of this inspection. You can see some protection around this structure would be there and some habitat are there. By combination of the geophysical survey, UXO, and visual inspection, we need to do the geotechnical survey. Why we need geotechnical survey? Because we need to know the soil parameters because our cable is buried. When our cable is buried, we need to know that what is the type of the seabed sediment because we shall do the engineering analysis for safe recovery of this cable. In this purpose, we should use some methods for the collecting the sample from the seabed and extract the soil parameters. One of the methods is using the wireline and rotary drilling unit, which can collect the sample up to 150 meters below seabed. Another one is using the cone penetration test CPT tools, which online provide the soil parameters along the drill area. And another one is drop and vibrocoring, which drop the core to the seabed by using a free fall winch and collect the sample. After collecting the sample, we should do the analysis and submit the report. We have some analysis and tests on board of vessel in onboard laboratory, and some of the tests should be done in onshore laboratory. For the report of the geotechnical, we will provide the details of the soil parameters, details of layers parameters, and also the results of onboard and onshore laboratory tests, as well as the graph of the CPT data. These data can be achieved online through the project, and also the borehole log will illustrate the seabed segment. I had a fast and rapid review from the Seabed Survey application for pre-decommissioning of the offshore wind farm. Thanks for your consideration.
Thank you very much, Captain Ilyati, and thank you very much, Mr. Bidawadi. Thanks for the informative presentation. I mean, we can see that what you propose with the subsea operation, which is I think that is totally similar between the oil and gas and the offshore wind industry. So in this case, we can use the same equipment and tools as you proposed. So the next speaker now, I would like to introduce the next speaker. But before going to the introduction, I would like to ask the participant, please, in case of having any question, on the right side of your screen, there is one module, question module. Please write down your question in the question modules. So I would like to introduce the third speaker, Professor Andres Olivares from the Western Norway University of Applied Science. Hello, Andres. Thank you very much indeed for joining us. I'm really delighted to have you with us.
Hello, Hamed. Thank you very much. First, I need to question that if you can hear me clearly and if you can see my presentation.
Of course, I can hear your voice and I can see your presentation very well.
Okay, thank you very much. Well, so my name is Andres Olivares. I work in the Western Norway University of Applied Science. We are part of this DECOM tool project. And basically, our university is large. We have around 10,000 students, but we are divided in campus. And our campus is in Haugesund. And we have a lot of offshore oil and gas industry here. So our role in this project is to try to bring to the table the know-how and the expertise from oil and gas and to the commissioning of offshore wind farms. So that is why I am here today. I'm basically going to talk about three things. I will describe briefly the Norwegian oil and gas and what has this to do with offshore wind. Second, I will describe briefly the decommissioning operations and the major trends about this technology and how this can bring know-how, transfer know-how to offshore decommissioning of offshore wind. And third, a little about the Norwegian infrastructure for decommissioning. So first, when people hear about Norway, they think of an oil nation, and that is partly true. Norwegian has been developed a lot since the 70s with the oil industry, and that is what you see in this graph with the green bars. However, in recent years, gas has been a major player. If you see the black curve that is in this graph, roughly the total amount of exports from Norway is 50% oil and gas and 50% all the rest. Okay, so oil and gas is a major industry in Norway. All the rest include a lot of technology development, but this technology development has been as well related to oil and gas. And in recent years, it has been a lot of talks about diversification of this industry, and that is coming from an early stage. Since 2001, the peak in oil production has happened in Norway, so that means that they are already diversifying from other services. But today, roughly is 50% oil and 50% gas. And just to give you an idea, around 25% of the total gas consumption from the EU came from Norway. So it's a very big industry. So then I borrow this slide from one of our partners in this project, from Hamburg Institute of International Economy. And here you can see clearly that Norway has no offshore wind parks. Okay. Most of the development in installation of wind park has happened in the last 5 years. You can extend it to the last 10 years maybe. But this is quite recently, and Norway has not been a part of this. Well, you may think that that is obvious, since that Norway was so focused in oil and gas, but it's a little more complicated today than that. In the year from 2000 to 2010, it was a strong interest in wind power in Norway. However, this didn't develop it well. So three main points why this didn't happen in Norway, and it happened in all the rest of the North Sea region. Well, one of the issues is that it wasn't a strong growth in revenues because the oil price was very high. So in the first 5 years of this decade, we were talking about $100 per barrel, and that disincentivate the offshore wind movement in Norway. There were, however, some research projects related to floating offshore wind. There was a pilot project that was very well known. But also at the same time in 2010, it was discovered the Johannes Sverdrup oil field. And that is one of the largest in the North Sea. So the expectations in the political agenda changed dramatically. And a third factor was that the Norway has a lack of domestic demand for electrical power because it rains quite a lot. So hydropower provides 96% of the domestic electric consumption. So somehow the political forces and the social forces didn't manage to push offshore wind power as a high priority in the first 5 years from 2000 to 2010, and then later from 2010 to 2020 was even more difficult. However, this has changed. We have a drop in the oil price. We have some things happen in the political agenda as well. So Norway has changed the oil and gas and diversification strategies back in the public agenda. And this is this company, Equinor, was before 2008 called Statoil and has been a major oil company in Norway owned by the state. So the decision to change the name came as a reaction to this. We need to diversify and we need to move from oil and gas. So this is high today in the agenda of the companies. And if you think about the Norwegian offshore industry, maritime industry is mainly related to oil and gas, but today that is changing. So this is a recent study about what Norwegian companies do related to offshore wind. And some companies, very few of them, don't deliver turbines, but they deliver components to the turbines. They deliver components to electrical substation. But the major area where they can play a role today is in the consultancy services, the engineering services, the vessel and the ship design for offshore wind installation and maintenance, and operation and maintenance. So this is the major area where these Norwegian companies are playing a role today in offshore wind, coming from the maritime industry in Norway. There are some exceptional examples of this. Fred Olsen, for example, is a Norwegian company that has a long career in maritime shipping. And they have a division, a special division that is relatively old. They started since 2012 with the first jackup vessel. It's not the only one, they have several. But this is an exception. There are not many Norwegian companies that are doing that today, but it's changing. So recent news, for example, August 2020, there are new developments for ships exclusively developed for installation. So the maritime industry is changing, and the oil and gas industry is also changing and moving to renewables, and offshore wind is something interesting for them. So that brings me to the second part, is talking a little about the decommissioning operations and the major trends that we see. So first I need to see that the decommissioning of oil and gas is a big industry and is going to increase a lot in the next year. The three major players around the world is UK, USA, and Norway. So this is a reality today. It's not the future, but as well, they see that it's going to develop it and the market is going to grow. So second, we have many different segments in decommissioning for oil and gas, but they are mainly two large groups. So one group is that what they are doing decommissioning primarily related to the plugging and abandonment of the oil wells. This is one big segment, and this is very specialized activities. They need to secure the oil well. So these operations are one segment. And the other segment that is the one that is interesting for this DECON2 project is the companies that are related to removal of the infrastructure, the large structures, the large metal jackets that are there. So these companies specialize in this segment. So you need to know that if you compare these two pictures, it looks similar what they are doing, but actually is quite different. And you need to be aware of these differences from oil and gas decommissioning. So offshore oil and gas structures are modular, and that make it possible to remove a complete module from the jacket. Offshore wind is not modular, so that is a different alternative. If you have modular installations, you can remove it by reverse installation. So to make it clear, here you see a large modular structure. This was built up as a module and it was installed as a module. So that means that you can take this module back when you are doing the reverse installation. And that is a big difference from offshore wind. There are several trends. The modules in itself are quite heavy. You can think about around 1,000 tons for a module. If you see in this picture, this large oil platform, you can think mainly about two large modules in the top. These are the living quarters modules, where the people go and live and have the offices and so on. And then you have the process area. And you separate two modules and you lift them in two operations. But in recent years, we see another tendency. They have been specialized vessels that can do single lift. And that is a recent tendency just because the market is developing so much and they make it so much cheaper. So this is a trend that we see, but however, we also see all kind of things. We have been interviewed with companies that are doing decommissioning offshore in Norway for oil and gas, and they also mentioned that they sometimes use small demolition. So that means that they bring the equipment, they bring the people to the oil platform and just demolish the part of the oil platform there. So this seems like not a very efficient way to do it. So we ask, why do they do that? And the reason is very dependent on the rate of the cost for the vessel. So sometimes the cost of the vessels can go so much high for these highly specialized vessels that it makes sense and is cheaper to contract the small vessels and cut everything into pieces. However, we have some few examples of this. Usually it's not the general situation. They prefer to move as much as possible in one lift. So there is a difference from oil and gas decommissioning and offshore wind decommissioning, but there are some things that can be used. We have identified some technologies that can be used, mainly cutting and cleaning technologies. Abrasive water jet technologies and high pressure pumping have been used extensively in oil and gas infrastructure. When I say abrasive water jet technology, is mainly water with sand that is projected with high pressure, very, very high pressure, 1,000 bars. So this is something that can be used. And another tendency that we see is that they try to automatize this process. So it's not, at least in oil and gas in Norway, you will try to avoid an ROV complex operation to do the water jetting. What you will try to use is to automatize the solution. So you will use a clamp. So in that way, the ROV can stay there and bring service or the power supply or the hydraulic power unit to the clamp, but basically the clamp need to work automatically. Beside water jet coating with abrasive, another technology that is very much in use is wire diamonds. Okay, so here you can see the same approach. You have a clamp that go there, and this wire is covered in diamond, very, very small particles of diamond, and that produce the cut, and that can cut almost everything. It's a little slow process, but it's usually done. What we know here is that the diameter of the jacket can be 1 meter, 2 meters, but a monopile offshore wind can be 4 meters. So that kind of tools need to be developed as well, but they have the expertise. So from the technical point of view, these companies don't see technical challenges to move into offshore wind decommissioning. Other technologies that are interesting, here we see, for example, the use of buoyancy for lifting operations. So this vessel can go under the sea line, under the water, just to lift some structures. And that is something that we have some early prototypes to think about how to use this for removing, for example, monopiles. So there is some know-how that can be useful. Regarding Norwegian infrastructure for decommissioning, there are mainly 3 ports that are specialized in Norway for this. However, they are not the only ones in Europe. The UK is also preparing for decommissioning of oil and gas industry, and they have also several ports. But there are some advantage for the Norwegian ones. So I will point to this this investigation from this report from the Scotland. They basically went in to see which are the ports that are prepared for decommissioning in Europe from oil and gas, and there are several in UK, but these 2 lands that are here are Norwegians, Vats and Sturt, and you see that they are very well evaluated by the report, especially regarding facilities. They are evaluated with 5 of 5 points, and sea accessibility 5 of 5 points. None of the UK yards are evaluated as high. So I just wanted to point out what this means in practice. So first, accessibility. Norwegian fjords are often very deep. So this gives them good sea accessibility for operation, especially with heavy lifting. This is a picture of Vats, and you can see that this is a very, very large crane, heavy lifting, and it has no problem to be operated close to the yards or to the quay. So sea accessibility is one point, but the other is infrastructure. They have Norwegian ports have very good infrastructure. The onshore recycling of topside structures require high technical standards to facilitate the waste handling, and this is very important. So these are not normal ports, they are specially built up to do these operations. So what means in practice this high technical standard? If you have dismantle activities onshore, the structures that are there, they may create some hazard for the environment. So the rainwater is going to percolate to all these structures, and it may be heavy metals, it may be residuals of mercuries and so on that will go with the rainwater. So somehow you need to address that this an environmental risk for this operation. So what this Norwegian port has done is that they have placed a membrane under the area that do the decommissioning, so they can collect all the rainwater and avoid contamination of the surroundings. So this is very expensive if you are doing to refurbish a port for that. So it needs to be done almost from the beginning. Sometimes companies like AF Decon in Norway, they use natural advantages as well. In this case, for example, close to the yard was a large cave that they can use to accumulate large volumes of water, and then they can send it to the processing plant to filter this water. So this is a big advantage if you need to build up this large containment for water, high water volumes. The cost is really high. So in short, what we have seen going to visit these companies is that they don't see big technical challenge. They are very much prepared to receive the commissioning of offshore wind in a large scale. They have the capabilities, they have the infrastructure. This hydraulic guillotine, for example, is using to cut into small pieces metals that are 50 millimeters of thickness. And they also have all the hydraulic components and try to automatize as much as possible of the process. So the companies in itself, they see it as not a really large technical challenge moving from oil and gas, the commissioning to offshore wind. But one thing that they see is that they require high volumes, they require large volumes. So they are not interested in the commissioning of 10 or 50 turbines. They need to have the bulk of the commissioning due to they have large investment in infrastructure. So in short, if you want to get some conclusions of my presentation, I will say that very important, Norwegian companies are diversifying. They want to go to offshore wind industry in Europe, and mainly all kind of maritime operations are going to be something of interest for these companies. But specifically regarding the decommissioning of offshore wind parks, these Norwegian ports, they need to have large volumes. So they are not going to be interested, it's just a small wind parks are going to be decommissioning. They are going to wait for the large ones to go. So this was my presentation. So thank you for your attention.
Thank you very much, Andres, for the presentation. Actually, it was a mixture of the technical and the field experience and the reports, and we understood that one of the reasons that the Norway does not develop so much offshore wind energy is that the price of the oil and gas doesn't make so incentive for the country to develop the wind farm. The second reason, if I don't make mistake, was that there's not so much demand. Actually, they are using the hydropower, so they don't need to locally, I mean nationally, they don't need the wind energy. And we saw that they are really advancing the oil and gas, which can be used all of the infrastructure in the offshore wind industry as well. So actually we have a couple of questions that some of them is relevant to the Andres and some of them need to be answered by Mr. Ilioti or Mr. Bidabadi. So the first question is for Mr. Ilioti for the Horizon GmbH. So how much is the required area or corridor to be surveyed for a geophysical site or route survey?
If Mr. Bidabadi is online, he can answer the question.
Maybe not right now.
Okay. Basically, for the corridors, as per practice in oil and gas, we are doing 300 meter for the corridors size. And for the site survey around the structures, normally we do 2 by 2, sometimes 1 by 1 kilometer, or sometime extended to 3 by 3 kilometers.
So can we say that these are based on the specific standard, or is that the common practice in the industry?
It's all depend on the client requirements and the practice in oil and gas industry. But generally 1 by 1 kilometer and 2 by 2 kilometer is a standard, the agreed format for all type of site survey, basically around the world in oil and gas industry.
Okay, thank you. So another question is that what is the accuracy of the surface and underwater positioning survey? Is again for Mr. Eliati.
When we are talking about this surface, basically we are using a satellite, we are using a Veripos systems and sometimes CNAV systems, and their accuracy goes down to basically below 10 centimeter. And when we are talking of underwater, basically positioning, sometimes the accuracy goes up below 1 meter. So sometimes even more, because it's depending on salinity of the water and the environments. But normally 1-2 meters accuracy underwater and 10 centimeter for surface positioning.
Okay, there is one question maybe I can answer, maybe Captain Eliati. They said that is that the UXO survey is really necessary prior to decommissioning, since the survey has been done prior to installation. It is unlikely that there will not be the UXO during these 25 years. So, will you answer?
Basically, I think the UXO survey is really required because of the historical data in Europe, and number of explosive has been dumped into the sea historically in past, and we are facing the same scenario even in mainland Germany. Every now and then there are closures of the area for removal of the explosive on land. So definitely, if the historical data of the field shows that there is a possibility of UXO, that has to be done.
Okay, and in addition, I saw a report that the UXO is subject to mobility, actually, because of the environmental condition, the current sea status. So they are moving, so they are not anchored to the seabed, so they are subject to mobility with the weather condition. And since they are so dangerous, actually, the objects and can endanger the life and the assets, so it is highly recommended to do UXO prior to decommissioning. Andres, I have a question for you.
Okay.
Are there any composite waste also in the oil and gas decommissioning?
Yes, they are, but there is very few. I mean, that when you have the living quarters, for example, you may use some fiberglass. So you will find this, and usually we don't know what to do with fiberglass. We cannot recirculate that. So this is part of the small percentage that cannot be recirculated nowadays. You have other things that are important as well. You have sometimes concrete things that are used cannot be easily recirculated as well. So there is a large percentage, I would say that 90%, everything that is related to metal can be recirculated or recycled without any problems. But these fiber components, these fiberglass, these are difficult to do it. So we don't have a good solution for that today.
Yeah, and another question just for the Andres, I think that it will be the last questions because the panel is supposed to be ended by actually by 12:30, and now we are 5 minutes behind the schedule. But having considered that the decommissioning of offshore wind parks that started with the Germany and Denmark and the UK based on the reports which has been presented by the Wind Europe and the Hamburg University. Do you think that it will be a business case for the Norwegian ports also?
Well, it could be if they are large enough. So, for example, today there are oil and gas platforms that are decommissioning in the UK that are bring to Norway. I know a few examples about that. So it's everything about logistic and cost. If they manage to do it cheaper, they will do it here. But I don't think that a small wind park will be the case. It needs to be a large offshore wind park. And as I said, the rate, for example, of the vessels is very important in how do you do your logistic. What the Norwegian companies are good on is in try to get money from the commissioning. It's very difficult to earn money and have a successful business case for decommissioning. There is no money there, so they are very effective with the logistics. That may be an advantage in the case of large volumes, but definitely not in the case for small volumes.
Yeah, thank you very much indeed for the answers. There are a couple of questions which we cannot actually address the questions because of the the tight schedule we have now. Now we have a 1 hour lunch break before we start the next panel, which with the topic of recycling, circularity, and repowering. So we are looking forward to see you again at 1:30 on the conference. Thank you very much for your attention, so we can put a closure on this panel. Good